Hi, I'm Miss Hearn. In this video, we're going to talk about z-tables for normal distributions and what are the different kinds. If you find this video helpful, please give it a thumbs up. That helps other students to find the video. These are standard normal curves. The shaded areas represent portions of data values in a set. The z-scores are the number of standard deviations from the mean. Those are the little numbers along the number line on the bottom. Z equals 0 is the z-score of the mean. Let's suppose that we were looking at z equals 1. If z is equal to 1, the region between 0 and 1 includes all the data values within one standard deviation above the mean, while this region, which is also next to z equals 1 but on the right side, includes all the data values more than one standard deviation above the mean. And this region, which is also adjacent to z equals 1, except shading to the left of it, includes all values less than the mean or within one standard deviation above the mean. Here's an example of a z-table. In this video, we want to try to understand how this relates to those normal curves that we were just looking at. Z-tables list z-scores and the areas of regions adjacent to them in the normal curve. In this z-table, the area A equals 0.371 is adjacent to the z-score z equals 1.13. But which of these regions does this represent? Does it represent the area to the left of z equals 1.13? Does it represent the area between the mean and z equals 1.13? Or does it represent the area to the right of z equals 1.13? That depends on the kind of z-table that you're looking at. There are several types. One is called cumulative, or cumulative from the left. In this kind of z-table, the area of the region to the left of z, or less than z, is displayed. This one's called cumulative from the mean, which means that it displays all of the area between 0 and the z-score. And this one's called complementary cumulative, or cumulative from the right. This shows the area of the region to the right of the z-score. Here's an example of a cumulative z-table. I found this one in Elementary Statistics 12th edition by Triola. You can see the normal curve in the upper left. It's like a map legend. It tells you which region is going to be displayed in the z-table. It shows the area to the left of z shaded. You can also tell that this is a cumulative z-table because it says cumulative area from the left at the top of the table. Let's suppose that we looked up z equals 0.45 on the table. So to find that, in the z column, you look for the first decimal place, 0.4. And then to get the hundredths place, we would look in the 0.05 column. Together, we see that it matches up with an area of 0.6736. So the area to the left of z is 0.6736. By the way, the total area under a standard normal curve is 1, so all of the values of the areas of regions are going to be less than 1. They're going to be decimals. Here's another example of a z-table. This one I found on www.statisticshowto.com, and this is an example of one that's cumulative from the mean, which is why we see the region between z equals 0 and whatever z-score we look up shaded. Remember, z equals 0 is the z-score of the mean. Let's look up z equals 0.45 again, looking for 0.4 down the z column and then 0.05 across the top there. We see that this matches up with an area of 0.1736. So that's the area of the region between z equals 0 and the z-score 0.45. This is a different number than we found when we were looking at the cumulative z-table, which makes sense because it's representing the area of a different region. Here's another one. This is a complementary cumulative z-table, or in other words, it's cumulative from the right. Let's look up z equals 0.45 on this z-table. Once again, we look for 0.4 in the z column and 0.05 across the top. And we find that the area associated with 0.45 is 0.3264. This is even a third different value from what we found when we looked up z equals 0.45 0.5 on the other two z-tables. And by the way, I found this z-table on www.2.stat.duke.edu. So let's compare the results of the three different z-tables. Each one gave us a different value because it was describing a different region, but there is a relationship between them. Let's compare cumulative and complementary cumulative. One thing you should know is that the total area under the standard normal curve is 1. And notice that if we add the two areas, the area to the right of z and the area to the left of z, we get 0.3264 plus 0.6736 equals 1. That's because one table is giving you the area to the left, the other is giving you the area to the right, and together we get the total area under the curve. This is useful because if I was working with just the complementary cumulative z-table, I could subtract 1 minus 0.3264, and I could get the same area I would have gotten if I was using a cumulative z-table. Now let's compare cumulative and cumulative from the mean. In order to compare these, we need to realize that because of the symmetry of the standard normal curve, an area of 0.5 is on each side of the mean z equals 0. So if we take away an area of 0.5 from the larger region, we should be left with the smaller region. And we are. 0.6736 minus 0.5 is 0.1736. So that's how those two regions relate to each other. So if I were to be using a cumulative from the mean z-table and I wanted all the area to the left of z, I would have to add back in the 0.5 that was missing. Or if I was using a cumulative z-table and I only wanted the area between 0 and z, I would have to subtract the 0.5 to find that region. Now let's compare cumulative from the mean and complementary cumulative. Once again, it's important to understand that there's an area of 0.5 on each side of the mean z equals 0. One of these diagrams on the left gives us the area between 0 and z equals 0.45. The other one gives us the area to the right of z equals 0.45. Together, they comprise the entire right side of the standard normal distribution. So if we wanted to get one given the other, we could subtract. 0.5 minus 0.1736, for example, is 0.3264. So we can see that all z-tables give different pieces of the same puzzle. I hope you found this video helpful. If you did, please give it a thumbs up. That helps other students to find the video.